Okay. Um, Hi, my name is Zhezhen Wang. So in this project, the goal was to develop a machine learning model that can help a financial institution predict whether a credit card application should be approved or not. Um, the project emphasized the responsible AI principles, because in financial decision making, automated system must not only perform well, but also remain transparent, fair, and interpretable. Therefore, the approach taken in this project is focusing on building a reliable model while ensuring that the decision-making process remains understandable and ethically responsible. The first step I did in this project was exploratory the data analysis. The dataset contains demographic, financial, and employment related information about applicants. Uh, these features include age, employment status, education level, income type, home type, and number of family members. By analyzing all these features, the distribution of these variables, and their relationships with approval outcome, I was able to better understand the characteristics of the applicants and identify potential patterns in the data. So, and I also checked for the missing value and duplicates to ensure the data quality was suitable for modeling. Okay, so this is my code for this part. Yeah, I just exploratory the data analysis and check the check the missing value and duplicates. Yes. So the next step will be the pre-processing. Um, So I prepared the data for the machine learning by convert all the numerical value, stabilize to ensure consistent scaling across variables. Categorical features were transformed using one hot encoding so that machine learning models could properly interpret them. The data set was then divided into the training and the test sets using stratified sampling to maintain the original proportion of approved and rejected the applicants. This helps ensure that the model evaluation remains realistic and representative of the underlying um, data distribution. Next, I trained and compared several classification models to determine which one would best solve the credit approval prediction problem. The models include the logistic regression, decision tree, random forest, XGBoosting, and light GBM. To evaluate these models reliably, I use fivefold cross-validation. But instead of only relying on accuracy, I focused primarily on the F1 score, which balance uh, precis precision and the recall. This is important in credit approval decision because both false approvals and false rejections will have business implications. A false approval could increase financial risk, while a false rejection may um, lower the customer satisfaction. Okay, here is the code. I did array to compare all these models and the F1 scores. And here's the result. Okay, so based on the results and the logistic regression achieved the best overall performance in the term of F1 score. the ROC-AUC, and the balance accuracy. Because of this, logistic regression was selected as the final model and further improved using hyperparameter tuning. Logistic regression is also beneficial from a responsible AI perspective because it is inherently interpretive, interpretable, which makes it easier for the stockholders to understand how the model makes the decisions. Yep. Um, this is what I said, the hypermeter turning for the logistic model. Okay, so when evaluating the turn model on the test dataset, the model achieved a moderate predictive performance. The accuracy was approximately 54% with a F1 score of around 0.22 and the balanced accuracy slightly above 50%. So I would say the number may not a very high score, but this outcome is expected in credit approval data sets where the positive class is relative rare, so the model still perform better than the random guessing and provide a useful signals for identifying potential approved applicants. Another important part of the evaluation was examining the model's learning curve. The learning curve compares training performance and the validation performance as the training dataset increases. In this case, the training and validation curves are relatively close, indicating that the model is not strongly overfitting the data. Um, the model is able to generalize the responsibility well to unseen examples, which is important for the real world deployment. Ensuring the fairness was another key component for this project. In financial applicants, machine learning system must avoid creating or reinforcing biases against certain demographic groups. To address this concern, I examined the model performance across in different groups, including gender and age categories. For each group, I evaluated metrics such as approval rate, recall, and false positive rate. By comparing these metrics across the groups, we can identify whether the model treats applicants differently based on the demographic characteristics. In addition to the fairness evaluation, I also applied techniques to reduce the impact of class imbalancing in this dataset because approved applicants are less common than rejected ones. I use SMOT to generate synthetic samples of the minority class during the model training. This helps the model learn patterns from both classes more effectively and reduces bias caused by the imbalanced training data. Yep, and here's the code, which is the ROC curve. Um, these are the threshold, and this is the learning curve I described. Okay, so the model explainability was also important for this project because credit decisions must be explained to regulators, internal risk managers, and sometimes even to the customers. Since logistic regression was selected as the final model, each feature has an associated coefficient and indicates how it affects the probability of approval. By examining these coefficients, we can identify which factors most strongly influence the model's decision. The analysis shows that the variables such as income type, employment status, education level, numbers of family members, housing type, and account length are among the most influential predictors. For example, longer relationships with the bank often increase the likelihood of approval, while certain income or employment characteristics may decrease the approval probability. Visualization these features coefficients help stakeholders uh, clearly understand how the model is making predictions. From a business perspective, this machine learning system could provide several benefits to a financial institution. First, it can help automate the initial screening of credit applicants, reduce the manual workload for credit analysis, and it can help identify promising applicants more quickly, which can improve customer experience and operation efficiency. The last one, third, because the model is interpretable, so it supports transparency and regulatory compliance. However, responsible deployment requires careful oversetting. The model should be used a decision support tool rather than a fully automated decision system. So human analysis should continue reviewing the borderline cases and monitoring the system for potential bias and the performance drift over time. Regular out of fairness metrics and model performance would help ensure that the system continues to operate responsibly. In conclusion, this project developed a credit approval prediction model that balance predictive performance with responsible AI principles. Logistic regression was selected as the final model because it provides reliable predictions while remaining interpretable and transparent. Fairness check and explainability techniques were incorporated to ensure that the model's decision can be understood and evaluated by stakeholders. By combining machine learning with responsible design practice, financial institution can improve efficiency while maintaining fairness, transparency, and regulating compliance in their decision-making process. Thank and just review the last part of the code. Yeah, yeah. And here's my presentation. Thank you.